Question 11 is optics. This one is pretty easy. So if I were you, well, I can choose anyone, but I think this one is pretty easy. Okay, so this is mirrors. Okay, this is 20 degree. This is 135. Determine the angle of, what is this? Angle of incident. Okay, so this is incident. Determine the angle of incident at mirror A. So some of you may just, oh, okay, isn't it 20 degree? Now please remember that the angle of whatever things is always measured from the normal. This is called the normal, okay, to my whatever ray. So this is the angle of incident. So 90 minus 20, it will give you 70 degrees. So therefore this is 70 degree. Copy and complete the diagram shown on a rating paper and show the blah blah blah. Okay, so please make sure you draw to scale. So for me, because I'm just going through, I'll just draw it. Okay, remember the arrow. Remember to state the angle here is also 70 degree. Okay, then you'll be able to get the 2 points. What my guess is that 1 point will be the ray plus the arrow. The other point will be about this 70 degree. Okay, then you are asked to determine the angle of reflection at mirror B. Okay, for part 3 is basically your mathematics. It is just simple geometry. So if this is 70 degree, then this one must be 20 degree. And you can see that this makes up a triangle. So if this is 20 degree, this is 135, what you need to do is, I want to find this angle, right? So I just take 180 minus 135 minus 20. I will get 180 minus 135 minus 20. I will get 25. So down here, this angle is 25. And please don't forget, draw your normal whenever a ray hits a boundary. So you are asked to measure the angle of refraction. So basically you need to find out the angle of incident again. So in this case, this guy here is 90 minus 25, it will be 65. And since it is a reflection, angle I is equals to angle R. So just put it in, and it's equals to 65. Ta-da! 5 marks, just like that. Much easier. Okay, diagram show a red light passing from medium A, medium B. Okay, state which medium A or B has lower optical density. So if you look at this, this is the angle in P, this is the angle in X, and if you can't really see the small difference, what I suggest you to do is extend this line so that you can see a reference. Okay, so you can see in B, the ray is actually bending towards the normal, meaning that my B is optically denser. Okay, since I'm going through optically denser, and this is optically less dense. Okay, so how will you explain? First, state which medium. So state it, my A has lower optical density. Full stop. The reason, the light or the ray bends towards normal in medium B. Full stop. That's it. Okay, then now they tell you that Q is 35, and they tell you that X is 45. Get the refractive index. So there is a distractor here. This, it is not the angle of incident. Angle of incident is measured from the normal to the ray. If you are still making this mistake, slap yourself. Okay, so this one, you have to get 90 minus 35, you get 55. Now if you look at this, it's another distractor. Okay, this is the angle of refraction because it's from the normal to the ray. Okay, so you are traveling from less dense to denser medium. All you need to do is very simple. I have no space, so I'm going to do it right here. So just take n equals to sine I over sine R. Put in the value. This is sine 55 over sine. Oh, wait. You can't use this formula. You cannot use this formula. Why? Why can't you use this formula? Isn't it less dense to denser? Now, if you want to use this formula, there are two limiting conditions. Condition number one, it must be from less dense to denser. Condition number two, one of your medium must be air. And in this case, you do not know. You do not know which one. Oh, wait a minute. They didn't tell you what is medium A. And they are asking you to find the refractive index of B. Okay, just to let you know, in this question they are assuming medium A be air. Okay, so you can still use this formula. But let me repeat myself. Okay, this is important. I think this question was not set properly, or the setter assumes that A is air. Okay, your Snell's law. All this equation n equals to sine I over sine R comes from your Snell's law. So what is the Snell's law? If you read your textbook, Snell's law is like this. Sorry. Let me. The problem with liquid paper is that it takes time to dry. Okay. But I really like liquid paper. Now, yes, this formula looks confusing. Now, what is this 1122? It just means the medium that these parameters are found. You can change it to NA sine theta A, NB sine theta B. Okay, and what it says is that, okay, refractive index of A. Theta A is the angle, okay, that the ray makes with the normal in medium A. So in this case, the angle A is 55. So you can put it in. I'm trying to illustrate to you why this one would not work unless medium A is air. Okay, I'm just trying to give you more information because you are doing pure science. So just put it in. MB you do not know. So sine theta B is the angle in medium B, which is 45. Now if you look at this thing, okay, you can actually, since you want to know the refractive index of medium B, you just make medium B the subject and you will get this. So far so good, right? Now what I want you to do is compare this with this. Just now I was doing halfway, right? Now you will see that unless the refractive index of medium A is equals to 1, only if this refractive index is 1, then you can say that this expression and this expression will be the same. Meaning that for this to work, okay, the refractive index on the numerator must be equals to 1. So the assumption is that medium A is actually air. Okay, if not, you cannot solve this question since they didn't tell you anything about the refractive index in medium A. So what happened here is that you have to assume, okay, NA equals to 1. Okay, then you can solve that. Oh, okay, my MB is sine 55 point sine 45. So I think the setter has actually forget to state that the medium A is air. So once you do that, do the calculation, you'll be able to get the refractive index of B. So it turns out that your NB is equals to 1.58. Okay, round up to 3SF. Okay, then after that, determine the critical angle. This is pretty simple. You just need to use this formula. Okay, this is critical angle, not the speed of light. So since you already know that, this is 1.58, this is 1 over sine C. C will be about 59.7 degree. Please do not make the mistake of writing 59.7 degrees C. Okay, then it is the last question. Oh good, I have so much space to write. Okay, since this is a video, I won't write it down. Okay, you try to listen to what I am saying. Okay, suggest a suitable material for the heating element. Now, this one you can actually find it from your textbook. Now, what is the common mistake made by students is that they simply state, okay, a suitable material will be metal. Well, you don't say. I know it's going to be metal, if not what? Wood, plastic? Okay, so please state the name of the metal that you're going to use and explain why. And the reason is pretty straightforward. Metal is a good conductor. So therefore, you use metal, okay? It is not because it has high boiling point, high melting point and all that. It's because metal has a good heat conductivity. So down here, go and state the name of the metal. Please do not use iron or steel unless you want to drink rusty water. Okay, refer to the textbook on the material. And then the reason is because it conducts heat effectively. Okay, surface of the kettle is polished. Explain why it is so. Now, when you boil, you must be able to understand what is the function of a kettle. Is to heat up the water, and you want to keep the water warm as long as possible. So if you want to keep the water long, okay, I will just write it down. So for your part B, okay, I'm writing down the thought process, okay, so that you learn how to think logically and derive and deduce your answer. So the purpose of the kettle is to keep water warm, right? You want to heat up the water and you want to keep the water warm, okay, for long time. So meaning that you want to reduce the rate, or you can understand it as the speed of heat loss. Right? You want to keep it warm, so therefore you want to reduce the rate of heat loss. And in order to reduce the rate of heat loss, you want to use a very poor, do you write poor absorber? No, right? Because you are not gaining heat. So down here you cannot write poor absorber. If you write absorber, you are implying that you are gaining heat. So what you need to do is that you are losing heat. So you have to either use the word emitter. You have to use the word emitter. Okay, you want to use poor emitter. This is your thought process. So how do you explain it? Oh, okay, so in this case, your silver, your polished surface is a poor emitter. Right, okay, some students will write polished surface is a poor emitter and a poor absorber. But why do you want to mention absorber? If you go and write down poor absorber, it indicates to the marker that you have no idea on the direction of heat transfer. Are you losing heat or are you gaining heat? Okay, once you put absorber, you are implying that you are absorbing heat, which indicates that you have no idea what's going on and therefore you'll be marked down. So, answer to the question, okay, based on the problem context. So here, polished surface is a poor emitter, so hence it will lose heat slowly and hence it will keep the water warm for a longer time. Finished. That's your part B. This is your thought process. This is what you write. Notice that the English I use is really simple. I don't really, I try to keep the sentence short and easy to understand. The shorter your sentence is, the lesser the chance of making mistake. But of course, when you make short sentences, make sure you have all the key explanation work. Okay, let's go back to the question. Explain why it feels hot when you put your hand above, okay, the kettle when the water is boiling. Now, the thing about this is that above, okay, you have to explain why is it that it is above. Okay, so explain the first part. Why is it above? Okay, the hot vapor would rise. Okay, Okay, and when the vapor condense on your hand, it will release what? You will release what? Okay, you will release what? You will release energy. Or if you want to be even more specific, you will release latent heat of vaporization. So hence, your hand feels hot. Full stop. That's it. Okay, then for your part D they mix it up with practical electricity. So if you have 2 wire, this 2 wire is actually your live and your neutral. The earth wire is missing. So why is the earth wire missing? Because the kettle has double insulation. Okay, meaning that the casing is already insulated. So when you touch the casing, it won't kill you, even if there's a fault in the circuitry. Okay, that's the whole purpose of earth wire. Purpose of earth wire, okay, protect the user from getting shocked when it touches the metal casing. Okay, when there's a circuitry fault. Okay, so if the casing is already insulated, then you do not need any earth wire because the user touched the casing, it won't get shocked. Okay, electric kettle, it has 0.8 kilowatt. Calculate the electrical energy used. Okay, they are already very kind, they give you kW. So you just need to convert this into kWh. So where do you get the H? The H actually stands for hour. So they tell you that it is 30 minutes. So 30 minutes is how many H? 30 minutes is 0.5 H, right? So how do you get kW into kWh? Well, very simple. You just multiply the thing. kW times 0.5 H. You will then get 4 kWh. That's it. Finish. Yes, kWh is a unit for energy. It's a unit for energy, not power, energy. Okay, if you want to know why, refer to the textbook. They have a full explanation on it. Okay, then you are about to find the cost for running it for 30 minutes, which is what we got here, right? So 25 cents per kWh. So now you're using 4 kWh. How much you need to spend? Simple. Just take 25 cents, multiply 25 cents, I change it to dollars, times 4. Because 1 kWh is 25 cents, so I'm using 4 kWh. So just times 4. So you will get $1. That's it. That's the end of the whole prelim paper.